Hi students, in this video I'll be going through the 2022 A Math Paper 1 question 2. Alright, so let's read the question. So when a substance B is dissolved in acid, a reaction occurs. Okay, the amount of B, m grams, okay, present at time t minutes after the start of reaction is believed to be given by the formula m equals to A times e to the power of negative kt. Okay, where A and K are constants. Okay, measurements of M and T are shown in the table below. Okay, so for this table, they give you some values of time, 1, 2, 3, 4, 5 minutes, and the amount of B remaining, okay, that's not dissolved, right? Okay, so they give you those values, okay? Okay, plot ln M against T for part A and draw a straight line graph to illustrate the information. So over here, they want us to plot ln M. So ln M will be on the vertical axis and T will be on the horizontal axis. Okay, the values given in the table is T and M. So this means that in order to plot ln M against T, we will need to compute the values of ln M. Okay, so basically what you can do is you can draw a table over here in the empty space, and then after that compute the respective values of ln M. Okay, so I'll show you how it's done. Okay, so over here. Okay, so over here you can come up with a table like this. Okay, so we just to calculate this 2.75, you will ln 15.6. To calculate the 2.49, you will ln 12.1. And then to calculate the other three values, the 2.25, 2.00, and the 1.74, you will ln 9.5, 7.4, and 5.7 respectively. Right? So after you have done that, you will set up the axis. Okay, so for the horizontal axis, which is T, it's very straightforward, 1, 2, 3, 4, 5, right? Okay, so horizontal axis, we always start from 0, so you just use 0, 1, 2, 3, 4, 5. Okay, so basically one big box, okay, for every one unit of time, right? Okay, then for the ln M values, which is on the vertical axis, okay, you need to observe the values. The smallest value is 1.74, the biggest value is 2.75. Okay, so this means that it's not necessary to start ln M at 0. Because if you start ln M at 0, from 0 all the way to 1.74, there will be no values to plot. So you'll be wasting space on your quiz, okay? So in this case, I would choose to start at 1.6. I always like to start at even, okay? Okay, instead of starting at 1.7, then you go up 1.8, 2, 2.2, 2.4, 2.6, 2.8, and 3. Okay, so more than enough space. Okay, so you set up the grids. Okay, once you have set up the grids, then you go ahead and plot the points. So plot the points with small crosses, right? And once you have done that, then you will draw the best fit line. Okay, so the best fit line doesn't have to pass through all the points directly. Okay, so you can see that for the second point from the left, my line is slightly above the cross. Okay, then for the second last point, okay, from the on the right, okay, slightly below. So it's a good balance. 3 points on the line, one slightly below, one slightly above. Okay, then of course, always extend your line to cut the vertical axis, because a lot of times we will need to use the vertical intercept later on in the question. Okay, so as you will see for this question, we'll need to use it immediately. Okay, so let's go back and read the question, the rest of the question. Okay, so they want us to use the graph to estimate the amount of B present at the start of the reaction. So over here, need to be clear. Start of the reaction, be alert. Start of the reaction means the time is equals to 0. Okay, so they want us to use the graph. Okay, use your graph. Okay, so basically what we'll do is we will find okay, let's go back down. Okay, so basically what we will do is, okay, we will find when time is 0, right? What is the value of ln M? Okay, we can't find the value of M directly because we have plotted ln M against T. Okay, so when time is equals to 0, okay, ln M is equals to, okay, so this one we need to use the graph to find the value. Okay, so let's take a look. Let's go back to revisit the graph. Okay. Okay, so you can see when time is 0, Okay, when the time is 0, it will go up. Okay, the ln m is 3. Okay, that's why it's important to draw our line through the vertical axis. All right. So when time is 0, ln m will be 3. Okay. Okay, ln m is equals to 3. Okay, then if you recall, ln is log base e, right? So okay, then we'll change it to the exponential form and we'll get m immediately. So this one is the base. Okay, then in the logarithmic form, this will be the power. Okay, so if you change it, we'll get 3e. This is the base. Okay, so this is the base. Yeah, I should write the other way around. Okay, so actually, I write this down. Okay, this is the base, and then this will be the power. Okay, so m equals to e to the power of 3. Okay, so that will give us 20.086. So round to 368, 20.1 grams. Right? So that means at the start of the experiment, there's 20.1 grams of B present. Okay, then as it dissolves in the acid and it reacts, it start to get smaller and smaller, the mass. Okay, let's look at the last part of the question. Okay, use your graph to estimate the time taken to the nearest second when 50% of B has been dissolved. So when 50% of B has been dissolved means the remaining amount is only 50% of the start, right? Which is at the start is 20.1. So basically what we need to do is now is calculate how much what is the mass remaining, which is 50% of 20.1. Then we'll find ln of that mass, so that we can use our graph to find the time, right? So let's do that. So when 50% of B has been dissolved, the mass remaining will be, we can calculate 50 over 100 times 20.1 gram. Okay, so we get 10.04 grams. So over here, I'm using the more accurate value, although I wrote 20.1 here. Okay, then we can calculate ln m equals to ln 10.04. Okay, then we will get 2.31. Okay, so we'll go to our graph, find ln m 2.31, go horizontally to hit the line, your graph, and come down vertically to find the time. Okay, so I'll show you what I mean by that. Okay, so we'll go here. Okay, so over here is 2.31. It is 2.2, 2.3, and then 2.31 is half a box. Okay, so we'll go 2.31 ln m, hit the line, and then come down and then find the timing, which is 2.75 minutes. Okay, so over here we are working in terms of minutes. So let's go back and complete the working. Okay, so from the graph, P equals to 2.75 minutes. Okay, so we convert 2.75 to seconds. Just take 2.75 times 60 seconds. Okay, then you to the nearest second you'll get 165. Okay, so this will be the nearest second. Okay, so this is how you do this question now. Okay, this question is actually quite an easy question for linear law. And it's a bit weird because they give the formula and there's two constants there, but we are not required to find any of those constants, right?